So we have this block that we can see here, and it moves along this track, this roller coaster type thing, and it goes through this circle and follows the path like so. So what we know, there's a couple of things that should stand out whenever we have a vertical circle. One is that if the object were just placed there, then the force of gravity, the weight, would be equal to the normal force. We know that would be the case. They would be equal and opposite to each other if placed there. But when we have the horizontal velocity that occurs, what we know is that the track, the force of gravity would be the same when the object is moving, but that there also needs to be additional force to bring about the centripetal acceleration. Because the object wants to travel in a straight line, but there's an additional force necessary to change its direction. And so that net force is the centripetal acceleration. Now, when we get to the top, if we just set the object there, of course it will fall because there's a force of gravity acting upon it. For the object to remain in motion around this, it needs to be traveling at a certain speed. And that speed needs to be large enough that it is moving and therefore accelerating faster than gravity would have it accelerate. The acceleration must be greater than the acceleration caused by gravity. If gravity were larger, then it would simply fall downward. You have to be traveling faster, and therefore you must be traveling faster than, have a speed sufficiently large that the acceleration caused by gravity is smaller than the centripetal acceleration. If you imagine that the velocity is 0, you're just at rest, the acceleration would be 0. The acceleration needs to be at least or greater than acceleration caused by gravity.